Oh, I have not given up. I have not even begun to give up. Or maybe I have become the long tail of giving up that will last for years and years and years before I finally give up. But not this day. Okay, so I mean, we're giving up on the floppy for VCF, but otherwise I'm not giving up. Alright, so let's take it easy a little bit because we know... Well, I noticed one thing, and maybe I'll zhuzh it on Friday. But I have an NES. It has a thing that comes out of it. It has a keyboard that plugs into it. You turn it on, and it says things to you. Except when it doesn't. Let's, You know, I just reset this video capture thing just before the stream started, and yet still, it just stopped working. Hello, Nico. Hello, Wereworm. Hello, Trey. Some classic names in the chat. So, shortish one today, but, yeah. Again, recap. At least for VCF, I have a thing. It does this. I have a keyboard. It goes like that. I should probably revise it to print a actual new line when I hit enter, as well as the carriage return, because right now it just does a carriage return, and that'll be easy to fix. So, like I said, maybe I will zhuzh that on Friday. There. And then people can just... maybe I'll still call it the NES guest book, but, you know, it will disappear as soon as you turn off the NES. But still, that's fun. I think if I make a little signage, people will be okay with it. Anyway, that's what I got. Right, so we had the next step being getting a floppy disk attached to this thing, and that hasn't been going so hot. What I think I'm gonna do is just take this board. The other day, when I started the Mega Stream Part 2 on Monday, I had things hooked up to a Raspberry Pi and didn't really have a lot of success, but I was setting it up for read only, and it really seems like to interact with this floppy disk controller, there are no registers that I am going to be able to read that will like give me a nice solid, oh, that's what that register is supposed to look like on startup type of value. So I think just going to we'll take things slow. We'll see if I can even interact with this thing at all, understand how to interface with it and what I'm doing wrong via Raspberry Pi, so I can control the signals individually. And let's update this to actually also allow for me to read and write from the thing. I'm trying to remember now, though. Wait, okay, yeah, so I was going to say, I'm trying to remember how I was controlling the read and write lines on this thing when I was originally doing this, and I wasn't. I just have chip select, which matches what the NES does, so that should be fine. But honestly, it would be nice to be able to also control some stuff. Be able to also control read and write directly on here. So how's about, I'm kind of running out of pins on these two gaggles of things are 74 series bus transceivers that are basically acting as level converters right now, because the Raspberry Pi Pico is 3.3 volts. But let me just generally get this plugged back in the way it was, and then like chip select goes right through, the address lines go, you know what I could do actually is, no, wait. Yeah, if I'm going to drive chip select on this thing directly, no, I just want to make sure, I was about to say, I just want to make sure the EEPROM doesn't interfere on the bus with things, but you know what? Problem solved. There you go. Okay. No problem. So now I don't need to, because right now this thing generates the chip select for this, and critically the read and write signal as a delayed copy of the chip select. which seems to match what they have on the data sheet, but I don't know, man. So what if I just also pop out the gal and inject my own, so I still need A0, A1, and A2, because those select what register you're accessing on the floppy drive controller. But now I don't need A17 and A18, which were previously being used to select between the EEPROM and the floppy disk controller, because I am just going to inject the chip select for this directly. So that frees up some wires for me. Let's see, I believe this was, let's start by just connecting up the data lines again, because those ones are easy, because this whole chip over here is the one for data lines. And it starts at 0. Okay, so this was input from data 0, which is at here. You know, I wonder if I had this backwards when I was wiring this up before too, but that wouldn't have really made a difference, because when I was doing Raspberry Pi, when I was driving this with the Raspberry Pi yesterday, my data bus was always 0, so clearly I was not actually driving the bus with the floppy disk controller, which seems to just generally have been the issue so far. It seems like I just can't, with the NES or with the Raspberry Pi Pico, I just cannot seem to get anything to actually cause this floppy disk controller to drive anything onto the data bus, which is really weird, because when I tried doing stuff the other day with the Pi Pico, all I got back was zeros, and when I was doing it with the NES, mind you, I still don't know if I was driving things correctly either way, but on the NES, I was basically just getting like a floating bus value of A0 that occasionally changed because, you know, floating bus. But it definitely wasn't driving the bus in that case either. So, yeah. Problem. Okay, we're 0, 2, 3, 4, 5, 6. And, you know, I'll have to double check. Presumably I was also driving power to it. It'd be really funny if I wasn't the other day with the Pi Pico. I need one more wire. Is this it? Are you it? Yes, you are. There is my... And now I'm actually also going to write some amount of library routines to to set this up and, you know, do like read from the bus and write to the bus commands that are easier to use and will sit in the Raspberry Pi Pico's memory, so I don't lose them every time it resets. Oh, right, which is going to happen because my hotkeys are still screwed up. If you were watching that one, my hotkeys for OBS, when I switch back to the display capture, it also resets. It causes Thani to reset the Raspberry Pi Pico, so that's fun. All right, so that's all the data pins hooked up. Let me, as I said, make sure like ground and power are hooked up. Might be good. So this is a ground over here. I guess I will put that in ground. And then did I have a wire coming out of plus 5 volts? Did I? Did I have that going on? No, maybe so. Ah, here you are. That will work. 2 of them actually, which makes sense because I actually, well, no, I was going to say, because I need that for the EEPROM for disabling write enable, but we don't have the EEPROM anymore, so it doesn't freaking even matter. So let us steal a wire. Free wires. Alright, so that should be power and data, and now I just have to connect up a token amount of addressy type things. which I have 8 pins available over here for sending control signals over that way. And I'm just going to keep my fingers crossed when I... Okay, so right now, so these chips, they're bidirectional bus transceivers. And I'm driving one at 5 volts and I'm driving one at 3.3 volts for the respective directions. And here's to hoping... Let's see. This first one that is controlling that is driving the data bus. So we have 3.3 volt signals coming in from the Raspberry Pi, goes through, and it should be, let's see, it's being powered at 3.3 volts actually, which I think is to make it okay with the 3.3 volt inputs here and actually trigger on them. Wait, no, it's coming around. So sorry, it's basically stepping. We'll have 5 volt signals coming in here from the data bus, and then these will be 3.3 volt signals so as not to fry the Raspberry Pi. But then, we're just going to have to hope. We'll see. So today might just end in 0 answers as well, because this doesn't actually have a level shifter on it, and I don't really have a level shifter handy, so this will step 5.5 volts down to 3.3 volts just fine, but when I switch the direction, it is going to, these signals coming out of here and going into the data bus are going to be 3.3, which I believe is technically below the threshold of this chip, but actually, wait, no, I can check. I don't think I've checked that chip specifically. I think I was looking at some other chips, and I'm thinking of something else. Let's actually look at what it says for, just so we can be a little bit more like, oh, okay, that should be okay, or that will be marginal, and be dang old sure, you know? It's temperature stuff, timing stuff, capacitances. Okay. See, I think I was looking at this. Okay, these are. I think I was looking at this, and I was trying to find out where. Oh, okay. So VCC can be negative 0.5 to 8.0. So, I mean, I'm driving... the question is, can I drive it with 3.3 volts? But it looks like the threshold for input high is 3.9 volts. So that's not amazing. The other option is just get another... I have some more of these 74245s. Get another one and have one be the inbound one and one be the outbound one, and run one at 5 volts and run one at 3.3 volts. Maybe. The question is, do I have enough cobbles for that? Wareroom says, could you not fiddle with the pins for the floppy drive to simulate a drive not ready or disk inserted or something that would show up in the status register? I didn't see anything immediately that goes straight from the floppy, like the actual pins on the floppy, as opposed to like drive, like vague drive status that is actually controlled by the floppy disk controller, like, you know, disk, like there's stuff like motor, like drive motor running or transfer in progress and stuff, but there's no like disk present value. I don't. Let's double check, because I mean, this is something I've thought about, but you mentioning it makes me want to look again. But in the meantime, I probably have enough. I probably have enough wires, so let's just attach the data bus to 2 sets of things. Oh man, that's going to be a hassle. So, if I don't have to do that yet, let's just not. Let me look at those registers again, because there was... The thing that makes me wonder is... well, firstly, let's look right here at this application note example thingy. because like most of these are outputs, like density select is an output. Index is an input, but I don't think I can really read that. But is there anything like... Okay, there's this disk change signal. Is that the disk presence indicator? Yeah, that goes into disk change. Can I see that? Because in the main register, I don't think so, but I think that might be what the... There's a register called digital read or something. 1 second, let's double check firstly on the definition of pins here. If at some point this wants to render the document. Disk control continued. Disk change, it is an input. Ah ha ha! You know what? You know what, Wereworm? For once, you've given good advice that actually was given at an opportune moment, and let's just do that. Because that's exactly what I was thinking. I thought I had seen that out of the corner of my eye. Let's do that. The digital input register is somewhere. It is read at 111. And then I think the status of that pin shows up in the low bit. Wereworm says for once. To be clear, Wereworm always gives good advice. It's just that sometimes I don't take that tack, or I've gone too far in another direction. But we've taken Wereworm's advice before. Yeah. Thanks for Trey for answering Nico on the. Nico asked what's the to the left thing, and yeah, Trey, your answer is correct. It's a joke, a non-intentional joke, kind of. That's just kind of hung out there. Gerald says, in regards to testing, do you have a cleaning disk that would work? That is way past where we're at, just FYI. But also, I don't. Wereworm says, hopefully it works without an init sequence on the controller. Yup. I've been wondering the same thing, because, I mean, it wouldn't make any sense, but it would also be really funny if, like, a bunch of these registers, like, are just invalid until I write the proper sequence of init commands to it, which is also a possibility. That wouldn't be the craziest thing I've ever heard. But yeah, let's look at this documentation on the digital input register really quick, and then that means I don't have to futz around with the Pi Pico too much. I probably will still want to. My kind of vague plan here actually is, since I can take things a little bit easier and go back to going a little slow, because I have what I'm going to have for VCF. Like I'm gonna see if I can just like start doing basic driving the floppy stuff using a Pi Pico for starters, just to make sure I can learn this chip properly, and then transplant what I've learned over to the NES once I feel fairly confident. But okay, here are the registers. It was digital input register. Yeah, digital input register. And no, not PS2 mode. That's why. Not Model 30 mode. Where was... Did I totally miss AT mode? Which is also what this is supposed to be in. Digital input register, PCAT mode. This register is read-only in all modes. In PCAT mode, only bit 7 is driven. That's what I thought. All the other bits remain tri-stated. So of course there is no hardware reset state. Disk change monitors the pin of the same name and reflects the opposite value seen on the disk cable, regardless of the value of invert. The disk change bit is forced inactive along with all the other inputs from the floppy disk drive. Wait, what? Am I reading from the wrong column all of a sudden? I don't think so. The disk change bit is forced inactive along with all the inputs from the floppy disk drive. All the other... What does that even mean? Is it... Am I unable to read and parse things right now, or does that not parse? Yeah. So the disk change pin. Yeah. It's going to be the inverted value of whatever's on the disk change pin here. Yeah. And it just says the disk change bit is forced inactive along with all the other inputs from the floppy disk drive. When? At what time? When it's being reset? When it's in power down mode? When it's... I think this is just a badly written document. I think I'm going to ignore that sentence. Because I have no idea what they're trying to say there. But... yeah. Oh, no, they totally are. Yeah. No, they totally are. They just didn't write power down state. That's what I thought. The disk change bit is forced inactive during power down state. See this 0 here? Yeah. So if it's in power down state, it always returns 0. Way to not include that word in there. Thank you. Thank you very much, Intel technical writers. Anyway, enough waffling. Let's plug some wires into some holes. So I think all I need now are... let's see. So this was I was using this one for chip select, if I do recall. Also just making sure everything else is wired up somewhat reasonably. I think it is. And right. So that one comes out this one, and this is the one I was using for chip select. Not that any of these have to have fixed purposes, but that's what I was doing. And I'm just going to jam that right in to the pin that the PLCC was sending out for floppy disk chip enable, which is pin 18. So that is 20, 19, 18. Jam it in, probably ruin the socket. Whatever. We can get more sockets. Okay, so that is going to directly control floppy disk chip enable. Then the next one over, I believe these are the ones that I was using for the address. And that should be his address. It's GP8, GP9. That might have been a screwy thing as well. I think when I was first working with this and I realized my wires were not lined up correctly, and then I moved them all over because they weren't skipping a ground, I still managed to have a wire plugged into the ground. So that would make selecting registers kind of difficult. Okay, there we go. So this pin is, why are you going there? Oh, that is the most significant bit of the data bus. Then after that, it's GP8, GP9, and GP10 are driving. Let's find it again in here. So this is GP8. Yes. Which I'm going to use for address 0. And where was that? Actually, wait. Let me look at the pinout. I was going to say I feel really confident that it was just adjacent to the low data lines, but I could be incorrect. D0, A0. Yep, cool. So, let me find these wires again, which is fun because I did 2 greens in a row, so if it wasn't confusing enough. So that should be A0, A1, and this brown one is A2. Theoretically. Remind me to actually probe those a little bit later to make sure that I'm controlling the things that I want to control before I just go blasting full speed at it. And then these last two, I think I was using for A17 and A18, but we don't need that no more. So, let's see, and that is, what is that? Oh no, I have 3 whole wires here for doing things. Wow. And those are just connected up to, let's see, I already did the chip select, I just did the low address ones. And it looks like GP11, GP12. Okay, I must have been using those for A17 and A18. Which would run across to these two. So, whatever, I will just use these for read and write, which is, I think, all I need. So I had pin 14 was going to the floppy disk write control. This was 18, 17, 16, 15, 14, which is, let's all try and remember this, going to be on, for some reason I have chosen GP12. I'm going to write that down in my big notebook of notes that don't mean anything anymore. Okay, so GP 0 through GP7 are DO through D7. Then it was GP 8 through GP GP8, GP9, GP10 are A0 through A2. Then after that, we're going to have GP11 is going to be FDC write. GP11 is FDC write. GP12 is FDC read. And then GP13, I think, yes, GP13 is the one that I have going to chip name. GP13 is FDC chip name. So I think I just need to plug in GP, whichever one, GP12, yeah, GP11. Woo, it's a good thing I wrote this down. GP11 to the gal's pin 17. And I think that's all I need. I have chip enable, I have read and write, I have the data bus hooked up, I have the low address pins hooked up, and chip enable, and I think that's all I need. In fact, there is this nice little diagram in the documentation, just in case I totally misunderstood some of the names and purposes of the pins. There was a block diagram that I bet I'm not going to be able to find it. Sorry, just thinking to myself, I should totally just run a wire over, I have this extra wire, and it's an output, and I should just use it to drive disk change. That was what it was called, right? Disk change? Oh, here we go. Yeah, so host interface logic, read write, A0 through 2. The DMA stuff, which I think if I just leave that floating, well, who knows? Maybe that's also screwy, is that I shouldn't just leave. I don't know if I did leave the DMA stuff floating when I originally wired up that chip, but if we do this experiment and we still don't frickin' see the disk change signal in the register that should just reflect the disk change signal, then I got no answers. Oh, you know what we do need? Damn it. Okay, no, I'm gonna have to just drive disk change manually, because you know what we need? You know what this extra wire was for? It was for reset. That's why there's solder on it. Solder, if you will. So let's just hook that back up. I never actually ran a... No, I never ran a PLCC pin, or a GAL pin from the GAL to the reset on there, ever, I don't think. I started thinking about it when I was trying to get the, get my little flip-floppy register thing working that never really worked. But I don't think I actually hooked anything up. Whatever. That pin's... there's no GAL in there, so it wouldn't be connected to anything anyway. Try to get in here without actually melting any wires. Moved the camera slightly today. Hopefully. I feel like my big head is going to be even more present. Come on, I don't even need you to be good. I just need you to make some connection. I believe in you. Do you want me to just go get an alligator cable? Because I will. There. That's good. That's making a connection. Again, remind me to actually check. Okay, that is everything I suspect. I suspect. Let me plug this in, go over to the Thani, and read the chat. Thani, do I still have you up? Yes, I do. Here you are. You can't see it, just trust me. Stop. There we go. All right. Okay, let me read some things. Wareroom says the write protect should also show up in the controller registers, I would guess. You would think... I'm not even going to say anything because, I mean, at best I have seen that out of the corner of my eye, but I didn't see anything register-wise that was immediately like, oh, there is the one that shows write protect. So write protect might be done in... Either I missed it entirely, probably, or write protect is handled in hardware. I feel like it might be handled in hardware on that thing. I also thought it had a 512-byte internal buffer, which is totally wrong, so whatever. Gerald said, yep, sorry, thought you were trying to trick a drive to generate signals. Way to use the IDE 1.44 3 1/4 drives. You're using an actual floppy, not using shorthand for diskettes. Yeah. That is the plan, is to actually hook up some spinning oxide to this bad boy. Trade MC says om nom nom, which I'm sure is related to something I was doing. This happens every time. I have no idea what it was. But either way, I like it. Lala says, what's the plan after floppy? I mean, the original plan was supposed to be Microsoft Basic. So at this point, since I'm playing with the floppy disk controller anyway, due to my misguided plans for VCF, that I was told was misguided and that I agreed with was misguided, I just want to put that on the record. This is no surprise that it's not making it to VCF. It was porting Microsoft Basic, but since I'm doing the floppy thing, then I think I might flip things around and start with like actually writing a small monitor program for the NES. Maybe not even a program, maybe just a real simple floppy bootloader to like read the first sector off the disk, load it into a area in memory, start executing it, and then go from there. And then once we have that going, run BASIC off of floppy, so that BASIC is just a thing that our NES can boot off floppy, which I think would be sick, because then we could have BASIC, but then I can also start writing, if I chose to, I could write like NES DOS. Now that would be a PC. but probably not. I'll probably just get basic booting off of a floppy would be fucking sick. So if that's the best I can do. Anyway, that's my rough thoughts. They're all rough thoughts. They change as they go. Oh, Trade MC was saying om nom nom to the alligator clips. Oh, Wereworm, are you looking at the documentation too? Cool, because he says, yeah, because of the stupid AT mode. In the other modes, more status data is visible. Yeah, I know. I should probably just... It's just because that one pin is strapped to VCC, and if it were strapped not to VCC, because it's that pin and the... I think it's... Oh, the MFM pin. And if you... I think I probably just left the MFM pin floating, and I think if MFM is floating and you ground... if you're looking at documentation, you're probably way ahead of me, but and you ground the whatever I just called the other one, the PS2 mode one. I could do it in PS2 mode, and then I could do I probably shouldn't have just done this in PS2 mode. Maybe we'll do that because I'll have more registers and whatnot. But back to the test. Back to the testing. Let's get a wire for disk, whatever the hell that was called. Disk change. Alright, what pin on the floppy connector is disk change? Because I wired this plug up, I remember that for sure, to be like a standard IBM PC floppy disk connector. So let's look at IBM PC floppy disk. Maybe just floppy connector pin out. I wonder how that works with multiple drives, because there is drive select pins. I wonder if it just there's probably logic on the floppy disk itself that only sets or clears that based on what drive is selected. Probably. Pinouts.ru, classic. Disk change rays on pin 34. Which one is pin 1? Pin 1 is always in the same place that I don't remember. Are they numbered inside the socket? No, there's just a nice little thing that says 3N. Oh, there's my pin 1 indicator. So this should go. Well, I guess it's the last pin, right? Let's just make sure. I really like counting. Counting is my favorite. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Wow, what a shock. And just to be sure, let's continuity check that stuff. I say, give me a beep. Give me a beep, beep, beep. And what pin is that on the actual floppy drive controller? Doody doody doo. Where are you? Where do you hide? You hide. Disk change is pin 31. I feel like I've probed this before. Ident was pin 27, which is this lower left-hand corner. More counting. Disk change, 31. 27, 28, 29, 30, 31. Wait. Oh, well, firstly, I have it on voltage mode. That's fun. 27, 28, 29, 30, 31. Oh, wait. I think I just wasn't making good contact. So, firstly, apparently there's some connection between ident and disk change, but whatever. 27, 28, 29, 30, 31. There, okay, yeah. Yeah. Super good. Beep. Beep, I'm an electric sheep. Lawless says, yep, that would be sick as fuck. I agree, Lawless. Tell me more things about how cool my stupid project is. Good. See, this is why I stream this, so I can have random people just pop in, and it's self-selecting, right? If you're like, what the fuck is he doing? Who cares? Then you're immediately gonna jet. But for the 5 people that are like, hell yeah, what a stupid idea, I totally get it, they stay, and then they tell me how great it is. So I just need the ego boost. That's why I do this. Okay, so I know that pin is disk changed, so how about I just wire that straight up to ground, because it will be inverted when we look at it. And yeah, there's a test setup, I think. Oh, I should probably make note of reset is on GP15. And then I can start writing some software based on that. GP15 is FDC reset. And sure seems conspicuous that I'm skipping GP14. But I am. I just am. There's nothing plugged in there. What? Who did this? Oh, is it because it's because I shifted everything down because of that ground thing, and then never actually... Oh no, I just can't read. That is GP14. GP14. Okay. Let's start with the sanity test of just make sure I actually friggin' connected everything right. Let's get Thani up in here. Close this shit, even though that seems cool. And I guess I can start working from this. Like I said, actually saving code to the Raspberry Pi Pico like a madman. Who would do such a thing? It bothers me that the tiling in Windows 10 got pretty cool. Maybe, I haven't used Windows 11 yet, so maybe it's cool. But like the fact that I like that if you snap them side by side and then it's smart enough to allow you to, drag the center point of them, which is nice. Nicer than what you have in OS 10, which kind of irks me, because otherwise I love OS 10. But, well, because in OS 10 you have to do full screen side by side. You can't have like them on the desktop side by side and have the middle point drag. Anyway, the fact that, and this is one thing that OS 10 has that Windows doesn't have, and KDE has had for about a bajillion years, is like giving you some resistance when you get to the side of this window. There's just none. What is up with that? What? Is that hard? Anyway, that's been Joe complaining for the day. There was no need for that. So I hope you enjoyed. Alright, so this should pretty much match what I have. Data is pins GP0 through GP7. Address low is an output pin from GP8 to GP10. Address high is not a thing that exists anymore. Chip select is 13, yes it is. Reset is 14, yes it is. And then Werb is 11. Word is pin 12. Am I missing any pins? I don't think so. And yes, let us save this as main.py on the Raspberry Pi Pico. So when it starts up, okay, let's test this. When I do Control-Shift F3, Control-Shift F2, which F3 brings up Find and Replace, and F2 resets the Raspberry Pi. But, oh, it probably doesn't execute the main every time, does it? Or, yeah, Does it? Does it? Is it possible for me to... Hi, I don't know Python. Nope. You can't do that. That's not how that works. That's not how that works at all. But I'm also guessing, yeah, this isn't defined, so... I think I just have to do this. Okay, cool. We're good. That's still... Yes, excellent. Okay. So, since I'm doing that kind... Oh, no! Slow down, me. Slow down. Okay, let's do this one by one. We can write utility functions and test things at the same time. So, for instance, let's write a little function to dump the data bus. Let us just do stuff. I am bad at Python. Let's call it def print data bus. Sure. And I think all I really need to do is do that whole lambda deal that I was doing before. Or no, I wasn't. Yeah, wait. There is totally a nice string concat function, I am sure. Because if I could just do, like, map, lambda... I'm a C# developer by day trade, so the fact that I can't just, like... The fact that, like, map and, like, functional style reduction and other, data transformation kind of functions exist in Python, but, like, you have to nest the living fuck out of them, irks me to no end. Which is annoying, because honestly, I really like that, if you want to just, like, mess around with something really quick, you can't go wrong with Python. I can't deny that. But the fact that, there's not just, like, an extension where I can do, like, data.map or something, it's gross. I guess that... Well, no, I was going to say, I guess that would also be true of stuff like JavaScript. But no, in JavaScript, like map and stuff is a method on array. So anyway, shutting my butt. Because I don't know what I'm talking about. So let's do... the worst way to do this. Dot format x, or no, x dot value. There's also probably MicroPython methods for, like, grouping these pins together and just printing them as a value, which should... Let's just ignore that real quick. Data, so that will give us a list of strings that should be 1 or 0 or 1 or 0, 0, 1 or 0, 1. And then, does Python have a nice string concat, string join thing? Python string join. Yes, okay, cool. So, again, slightly gross, but it's probably because I don't know what I'm doing. And that's probably going to be backwards because my most significant bit is the last thing in the list. So, I can reverse them though, right? Python, list, reverse. Wow, look at that. And data should be a list. Okay. So if we save this up, run it again, and do print data bus, then we can't iterate over nothing. Alright, cool. And at which point is that the problem? Okay, let's just start here. I doubt it was the join, but whatever. Save it, run it. Print data bus. Nope, wasn't that. What is Oh, hold up. There's one thing. Is... Well, it should just be printing the return value, right? Because I was going to say there's no print in there. I should have wrapped this all in a print, too. But let me look at chat to see if anybody knows Python better than me. Wareroom said, I wonder how the system is supposed to detect a write-protected disk when in AT mode. Like, I think that's the place where, like, traditionally it's in hardware. Like, something in the back of my head, something itches in the back of my head that I had once read at some point in the years and years ago that I had first started messing with this floppy controller, that in AT mode, if you try and write it with the write protect not set, or, you know, with the floppy indicating that write protect is on, then it just won't actually send any data to the head. But, yeah. Loved how my Amiga detected the disk change. On my Atari, I had to click OK on the insert next disk dialog. I was always jealous of that feature. Yeah, I still don't get, because, like, PCs definitely have a disk change detection. We're looking at it. But, like, how old am I that I don't remember at this point if on a PC it could automatically detect a floppy being ejected and inserted? Like, I feel like the only thing they used that for was turning off the motor. Am I insane? Anyway. Yeah, man. And on the Apple. Very nice on the Apple. The little things, you know? The details. Alright, so let me just make sure data is actually something. Yes, it is. Data.reverse is nothing. Fucking why? Oh, because it reverses the whole list. That's right. God damn it, it reverses it in place. Gross. Oh, gross. And I'm sure if I just assign that to a different variable, it's still pointing to the same frickin' object, so if I move it to a different variable, if I assign a different variable, and then... Oh my god, that's gross. There's probably an idiomatic way to do this, but if I do, like, reversed data... But I want to do this in, like, a transformation type way. I just want to do it in line. Data, let's look. Python list reverse with... oh! I think it was Trey or somebody the other day telling me... Oh, W3 schools. Yeah, sure. Why isn't there just a Python docs page for this? Geeks for Geeks is probably the least bad option. Totally was saying something, trailed off, forgot what it was. Oh, no, it was this. Is that I believe Trey Dempsey was telling me, why aren't you using list comprehensions? So I'm going to try using a list comprehension. Okay. Uh-huh. No, get out of here. Okay, so obviously it can be used for filtering. Python. Was it just saying reverse a list comprehension? Probably. I thought it was maybe some people were searching for using a list comprehension to reverse a Python list. I think that was naive. Let's see. Python list reverse order not in place. That's not going to turn up in results. I don't want to reverse in place. Let's see if anybody says anything good on Stack Overflow. Please, somebody who's good at Python, please, please start following my channel. Please. Oh god. See, this is my thing about Python, and I know it's just because years of cruft. It's been there for a long time, but like some things are methods. Some things are just global functions. And I know it's because the global functions just were there first. But like the fact that the idiomatic way to get the length of a list in Python is calling the global len function on your list makes me, it hurts me. It physically hurts me. This is, again, just me speaking of my experience. If you love Python, that's totally cool. I don't mean to denigrate Python as a whole. Probably should, you know, call the function. Oh, reversed. Uh-huh. Okay, let's just do this really quick, just to make sure. Because I would have expected, I would have gotten a list of... No, I would have expected a... What language do I think I'm writing? You kind of have to return values. We'll get there, slowly. So hopefully this should give me a list of strings. No, it should give me a map object. Yeah, there we go. So let's finally do join. I think this will do it. What? Let's try listizing that map. Let's try iterating that map and see if that makes a difference. What? Oh, you moron. There we go. There we go. I'll get there eventually. Okay, let's see if join can work on arbitrary iterable things. Yay! Wrong, but yay. What? Huh? All ones? I guess that's just the way it's floating. I have no pull-ups or pull-downs on here, so let me try rounding some things data side and just make sure these go back down. The fact that there aren't pull-ups or pull-downs on them is fine, but I just need to make sure that I can see changes here. So I'm going to probe directly on the IC. Let's see. Just start at D0 and start poking. Yay! Okay. That's good. I want to be thorough, okay? This might take all day, but I want to be thorough. I want to make sure I know what I am doing. Because you can't really prove that the thing that you're testing is working or not if the harness doesn't work. But the data bus, it works. It works. It's wired up fine. Okay, and now I've written some code that actually will stay on here, and we won't lose it every time that we do this. All right. Let me check chat a little bit again. Let me just check it. Starting from where we left off, Trade MC says, PCs could not detect disk insertion, but floppies supported it if they wanted to use it, e.g. Amiga Mac. But what I'm saying is, I'm using a PC floppy disk controller right now, and it has a disk inserted signal on it. It has a thing there. It goes all the way to the floppy. It's on the connector. It flows through here. You can see it in the register. And they just never used it. Trade MC said they're like a map, fmap, the list comprehensions. Yeah, that's pretty much what I thought. Then he says just use reverse. Dirt Piper says they're good with Lua. I'd like to play with Lua at some point. I'd like to play with a lot of stuff. I have a ideal scripting language that doesn't exist, and also my demands are probably weird. Mostly I want, like, JavaScript that isn't bad. I don't know if anybody gets what I mean. I like curly brace languages. That's just a preference. I don't think they're better or worse. I just don't really like offsides rule stuff. But I like all of the, I hate to say functional affordances that they have put into JavaScript of late, but all of that. Because it's not really, because it's not a functional term, gets overused. Just filtering stuff, filtering and mapping stuff. And that said, talking functional stuff, if it could have currying, that would be cool. But also just like having first-class functions, all that good stuff. First-class functions in Python blow chunks. Lambdas suck. That's all I have to say. Lambdas in Python suck ass. That's pretty much it. I just want a curly brace language. Give me first-class functions. Give me a nice set of mapping and mapping, reducing, filtering, primitives, and currying. That's all I need. Santiago says +1 for curly braces languages. I think it's because of my scatterbrainedness, and when you're using a curly brace language, you can write in whatever stupid monkey brain style that you want. So I think that's why I prefer. Wareroom says, yeah, you mean the reversed function? Reversed. Trade MC says use list.reverse. Too late. I'm sure that would have been helpful. Wareroom says I can help with Perl. I have never once touched Perl. I want to just for the experience, but I've never done it. Trade MC says I can help with Python, but he's gotta read chat. You should know by now. Wareroom says I love the destroy all software WAT lecture. It hurts, but it's in a fun, morbid way. That sounds up my alley. Trade MC wrote my terrible expression as a list comprehension, and it looks way better. So, fine. Dirk Piper says Lua is my ideal scripting language. No arrays and tables index starting at 1. I mean, that's one of the reasons that I would play with Lua. Is I mean, people who like Lua love it, absolutely love it, and you don't hear that much with languages. Like, people usually either like it, dislike it, haven't used it, and that's about it. So the fact that people who like Lua are crazy about Lua, yeah. Lua has the very terse end. Yeah. Well, yeah, does Lua have... Because Lua isn't... It's not curly brace, but it's not white space. Meaningful white space, right? It's like basic, basically, like the Visual Basic style things. Reverse doesn't reverse a list, so you have to reverse it in place. Data.reverse then prints the list. Trade MC points at the Rust R in his icon. I know. Rust pretty much sounds like what I'm describing, doesn't it? But then, and maybe I'll get back to working at some point here. After we spend an hour and a half plugging wires into a board. Rust seems like my ideal language in all the ways except that, how do I want to say this? Okay, what I want to say is that I and it's stupid because it's the whole purpose of the goddamn thing is its memory safety features and borrowing and lifetimes. That's what I want to say. What is true is that I'm too dumb to use them. But also it's like I want... I guess I basically kind of want Rust, but as without those features and being like a garbage collected scripting language instead. And pretty much, yeah. Everything else I love about Rust. I love I love its way that it structures like interfaces and modules and implementations, and that is excellent. I think that's the way it should be done. Everything about it is great, except that I want to learn how to use lifetimes. That sucked too much. Rust is FP-ish. It's a fantastic language. It really is. Oh, you know what? What other one major thing that I actually really did find that disappointed me about Rust which shouldn't. It's not saying much because honestly, you know, there's a reason people were excited about Rust when it came out and when it, you know, started really blowing up. The fact that in Rust, lambdas all, and I realize there is a reason, but it was annoying to me regardless. The fact that all lambdas have a distinct type. So you can't just like pass them around like a function pointer that matches some certain kind of shape, you know, based on arguments and return value. No, even if they have exactly the same and again, there was a good reason. I looked it up. It made sense. But that means I can't use them the way that I really wanted to use them, which was a bit of a bummer. Like, assign them to a variable or pass them into functions and just, like, have them implement an interface. There's some weird crap about that. Trade MC says, it's an existential type, but there is a trait that you can use for function pointers. Rust is right on that edge of, I think there's the thing, is it's right on the edge of having C++ syndrome at this point. Which I realize is a really, really, really harsh thing to say. You cannot say that lightly. And it's not, obviously C++ has C++ syndrome bad. But there's just a lot of ways, like, there's a way to do something. You just have to learn a lot to do it idiomatically. But it's the best. JavaScript was my first language, and function all the things you only use once. Why? If you're talking about stuff like this, I'm going to use this regularly, but I don't think you are. So, okay, before I take off, because I've already run over what I wanted to do. Well, it's just over an hour, so it's not too bad, but I have stuff to do. Let's finish testing stuff. So the data bus is tested, and then I need to make sure each of these pins actually is connected the way that I think they are. And then PA stay resistance, let's try resetting it, chip selecting it, reading that register, see if we see a 1 in the 7-bit. Okay, so this should be fast. Let's just do these real fast. Oh, actually, you know what? This is one that I'm going to really want to use. Let's make a function for set address. And this is going to be annoying. Maybe. Is it? Let's just do it. Do it. For the incorrect way. 0 through, and it's non. No, it is inclusive. It is inclusive. No. Shoot. How many data bits do we have? Oh. Let me just comment this real quick. Just making sure, because last time I played with this, well, no, I already know. I poked them all. There are 8. Okay, so this is right. This is inclusive. I couldn't get this straight last time, but those seem to work fine, so it's inclusive. For I in range 0 to 2. Let's just do... what is that called? Adder low, which is a redundant name at this point. It should just be adder, but whatever. Adder low I. Let's see if I can do this, because I can't remember all of the methods that are available on pins in MicroPython. CS. Can I just do like CS equals 1? Will it let me do that? Did I just turn it on? Is this allowed? Is this allowable? It's on. I think that's the right pin. CS equals 0. Nope, you can't do that. Unless I just have that pin totes wrong. No, I don't. I do not. Let me make sure it's high on that side. It is high on that side. So, not the circuitry. And if I do cs.low, huh? Oh, you, damn it. Damn it. You moron. Don't mind me. I don't think you were looking at my screen, so I'm not even going to say what I did. cs.set. One could just read the documentation. But then it wouldn't be as excitingly frustrating for you guys. Nope. CS. Oh, wait. I think I remember. I think it's value equals? No, because that's... is it set value? Is it... Wait. Is there a version of the value function that I can pass the value to? Yes, there is. That's what it is. Got it. SV Discussion says, great channel. Yay. Worm says, when I type Rust is like into Google, it suggests cancer as the next word. Okay. Trey, I appreciate you writing the nice list comprehension. Oh, so yeah. So I can't do data.reverse because that reverses my actual list of data pins, which I don't want to do because then every time I do that, my list of data pins is reversed. So I'd either need to make a temporary list off of it and then reverse it, or reversed seems to be exactly what I want to do because I want to, filter and transform it, not actually alter the list in place. Okay, dokay. So what do I want to do here? Oh, right. Let's just do, I should be able to do dot value, and I think I can just do adder and 0 x I guess let's just do 1, and then adder equals adder. I think these kinds of shifts are supported in Python. I'm probably wrong, but we'll find out real shortly. Wait, let me wait for Trey. Oh, you just clone the list using list data.reverse. Yes, but you see, I have done this. I have done this thing, this horrible macabre thing, and it brings me much joy. I don't know how far behind chat is, but Trey, you gotta help me out here. Is right shift a thing in Python? I'm just gonna assume it is. Yes, they work as expected, says Trey. Yeah, I understand most of the operators in Python are stolen from C when good old what's his name originally developed it. So I think this is what I want. So let's try running this and setting an address. And let's do 7. Let's do 7. They should all turn on. Poke some things, poke some address things, poke them up real good. If you think I should put out an album of tunes hummed during live streams, comment below. So that's ground. Wait, no, pin 1's over here, genius. I get so confused because the socket and the ZIF are the headers and the ZIF are mirrored from each other, and okay, data. Okay, so that's address 0, that's address 1, that's address 2. Am I correct in my assumptions? I believe I am. Wait. Oh no, I do think I am wrong. Wait, yeah. It's D0, D1, D2 on the bottom left of this side. Then, no, this is ground. No, I was right. So the bottommost pin on the pin 1 side is ground. Then D2, D1, D0, A0, A1. Who knows? I probably got that wrong. You know who knows? The documentation. My brain's telling me it's time to think about quitting. I need the actual this thing. Yeah, no. A0, A1, A2. Just as I insinuated. D2, D1, D0, A0, A1, A2. Is A2 not connected? See, this is why I'm testing this harness first. Because if you're trying to figure out if a chip actually works or not, it would be really stupid if this harness just didn't friggin' work. Okay. Yes. No. My function sucks and does not work. Or, let's see. Totally possible that I am constructing the address low out of the wrong pins. Even though, I mean, I wrote this down. GP8 through GP10. Yeah. Let's just... Ooh, lots of Trey Dempsey. I'm trying to do my best to look at chat before I do any dumb Python mistakes. Trey Dempsey says I'm not a Python programmer, I just play one on TV. Better than me. I mean, I rarely use Python except for MicroPython on occasion. And, you know, it's one of those things. Oh, and it's very useful for if you just want to spin up a quick, you know, Flask thing to play with. But yeah, it's one of those things where I do it so unoften that I immediately forget everything the second I step away. Oh, Rust function pointers. I don't understand what you're saying, and it's not because you're not making your point correctly, it's because I am dumb. So function funky dance of type F, where the argument is named function and has type F. Oh. So it's the where F. Okay. So there are type constraints in the generic system where you can say it's a function that takes nothing and returns a string. I see what you're saying. Cool. It wasn't so much passing them around into functions, it was using them inside of the body of a function. Because I basically had assigned... Oh, no, you know what it was? It was that I was writing a clever one-liner to assign... I had two lambdas that did slightly different filtering functions, and I was using a ternary to assign them to a variable and saying, okay, if this is the case, then assign this lambda to it, and if this is the case, then assign that lambda to it. And because they are of two different types, you can't actually put them in the same expression because they are of two different types. Yeah. What is your planned vision for RAM later on in the BASIC? How much? The family BASIC only had 2K or so. Yeah, Trey Dempsey says, oh yeah, you can't do that. Well, it's a bummer. But I mean, you could do that a bunch of other... like it, using what you just wrote, I could just, you know, refactor it into two functions and then pass the function I want into the handling function. Anyway, Wareworm is asking, what's my plan for RAM? I believe the NES has 2K on board, but I haven't played with it yet because it hasn't been necessary. I was gonna, like, when I was originally gonna do this, I was saying maybe, you know, add some RAM onto the cart, and we could still do that because we could make like one of these. Once I run the write line over from the motherboard or from the cartridge, assuming it's available on the cartridge, I could map a big chunk of RAM into one of the map ROM windows. Would be a hack, but there actually is some amount. I think it might be 8K of SRAM on board the Super Mario Brothers 3 cartridge. That's one of the things that the MMC3 can like assist with, and it's optional for MMC3 cartridges, but this is one that happens to have it, so I think that helps us out because we'll have an extra 8K. That said, I believe from what I was reading, Microsoft Basic can fit in 1K. I think that's the minimum. I think you can build it for 1K configurations, so 2K or better should be fine. But more is always better. Okay, are you guys waiting on me to do something? Are you? That's ridiculous. Are these plugged in right? GP8, GP9, GP10. Yep, just making sure. That's not insane. Okie dokie. Okie dokie. So anyway, that means my function's wrong, my function's wrong, my function's wrong. That just means my function's wrong. What the living fuck? Let's do some print debugging. Let's do it the laziest way. Just say a thing, then colon, then another thing. And the first thing will be I. And the second thing will be ADDR and 1. And then we just print it on every iteration and we run it. And we say, yo, what the hell? What you doing? What the fuck is with range? Brother. I'm losing my mind. Print data bus. Print data bus. 1, 2, 3, 4, 5, 6, 7. Yup. This is the count. My suspicion about the other day was correct. So it's non-inclusive. That would do it. And we're just gonna, you know what? I said thorough. I said fucking thorough. Let me actually make sure D7 is connected. I mean, surely. But let's make sure. Blah, blah, blah. D0, D1. You can't see shit. D0, D1, D2, D3, D4, D5, D6, D7. Gotta run the thing. Gotta run the goddamn thing. Works fine. Would have assumed. Can't assume. Okay, which means that the entire problem with this is just that address low was off by 1, and this is off by 1. And really, because I should not be a fool, you know what I should do if I were clever is why would I do a this when I can just do a in adder low and this out of here. And instead of doing this, just do this. Ya fool. Got a good feeling that's gonna work. Yoop doop doop. Yoop doop doop. 1, 1, 1. Wow. 1, 1, 1. Wow. Set them all to 0, set them to something else. Call it a day for address lines. 0, 0, 0. Amazing. And just for fun, let's do set address to, I don't know. Let's set it to 5. Wait. Always got to do that first. Set address 5. Am I high? Unfortunately, no, I am not. On, off, on, amazing. Okay, alright. Okay, and the only thing left to make sure it actually works before I try doing this whole actually trying to read this one pin. Maybe we'll just save it for tomorrow. Maybe we'll try reading this register tomorrow. Remember when I said taking it slow, taking it easy, which would imply I should be done now? I might be obsessive. Yo, Megaton. Good to see ya. Okay. It's 1 hour and 27 in. That's not the worst. Okay, let's just sanity check. Sanity check. Chip select. Run the fucking thing. Yay, that works. Trust me. Yay, that works. The next one is... that right? It is right. So, verb dot value 1. Wow, it's high. Verb dot value 0. Wow, it works. You don't know until you know, okay? Verb dot value. One. Yay. 0. Okay. Oh, we had to do... Oh, we didn't do reset either. See? It's important. Otherwise, we miss things. Yo, that worked. Yo, that also worked. Okay, we have a thing connected to a thing now. You want to try reading that register? You want to try it? You want to finally see it? Pièce de résistance. So theoretically, chip's on. Technically, we just reset it, but let's reset it again. Reset. 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 All right, that should be theoretically a reset chip now. Now we set the address. Set address. It was 7. We set chip select. Wait Fuck. That screwed everything up. I need to have things in proper initial value, and they are... Ooh, let me check. I think I can get away with this. I think chip select is already high, which would be good. If it is low, I need to restart this whole sequence. It's already high. Whew, okay. Woof. Okay, so CS low. Then, here is the next one, is that read and write also need to be high. Oh, I definitely set right there. This is definitely set to 0. Okay, let's set some initial values. Chip select should be high. Read B should be high. Verb should be high. And we already have the address set. That's fine. The address can hang out there all day. Let's reset it again. I know it was already 0. I know. Okay. So the sequence is chip select high to select the chip. Read. No, I'm high. Chip select low to select the chip. Rub. Low. I gotta go. Wordb. Ridb, not robe. Low. And as far as I saw in the documentation, there is no maximum trailing value between chip select and read. And there is no maximum, like, there's no maximum hold time for the data. I think it just holds forever. I checked in the timings. I wanted to make sure. Okay. I expect failure. I hope everyone was here to see that. I hope Wereworm was here to see that, because that right there is, my friend, the right bit in the right place. And I have no reason to believe that is not the correct thing. So I guess this just, let's reset our stuff. So read be high again, chip select high again, and switch the disk presence detect to, yeah, I know, Lowell says define reset all. I was thinking the exact same thing next time, because I'm probably going to be doing that a lot. Okay. And also I should just also write a helper thing for read from address and do all of this. But next time. Here goes. It should be 0 now when we read it again. So, CS low, rdb low, print data bus. One more time, and then I gotta go. CS high. I'm curious. Is that connected directly to the data bus when you have that register selected? Let's see, because I have not. Chip select and read B are still asserted, and I just swapped it. So, that's fun. Yeah, it's directly connected through the chip. It's like just multiplexed directly through the chip. So when you have that address selected, it just dumps that pin, inverts it, and puts it on the bus. That's neat. Wereworm posts a big ol' I. And I gotta go. But the floppy drive controller works. We confirmed it. So lots of things to figure out with why it doesn't work with the NES, but let's keep this Raspberry Pi part of things going. Let's try try and control it a little bit to make sure I understand it. Connect a floppy drive to it. I don't know, maybe you guys vote about it. Yeah, you guys vote about it. You guys let me know. Think about it, let me know the next time I stream, because there is extra fun in knowing that this works, plugging it back into the NES, getting things working properly. Oh, one thing I want to test before I go. Oh, and then just, seeing the floppy drive work for the first time on the Nintendo rather than seeing a floppy drive spin up and do stuff on the Pi Pico. That would be there's a feel there that you can't reproduce. Anyway, so think about it, let me know. But I was going to check, I had that brainwave and then I lost that brainwave. It was something about resetting this thing and doing something, and a quick test, because here's a thing that we can test real quick. Kind of. Let me see really quick if there is a MicroPython command for setting the value of multiple pins at once. There definitely is. That I have worked with the RP2040 at a register level, and it actually has some kind of neat registers that let you set a mask for what pins you want to alter, and then set their value. So in one write, you can make sure they both change at exactly the same time. Did they implement a MicroPython command for that? MicroPython. Because I didn't say what I'm trying to do. I want to try, for my own sanity, no, I have no sanity. You had it there. You had it there for a second. Setting, chip select, and read at the exact same time. I mean, this should still be way fast enough that setting them in one line should still be fast enough to test this. And see if I can still read shit out of this chip. Because if I can, then that means that's not my problem on the NES. Let's do that before my mind finally explodes. MicroPython pin set multiple pins. Set pin values synchronously. Yes, this is exactly what I want. You can write directly to the GPIO registers. I could do this, but I won't. We'll just write them both in one line. And so let's do this sequence. Let's run a sequence. Deassert chip select. Deassert, not CS. Deassert RUDBA. Reset the chip. Reset high. Reset low. Just to be fucking sure, let's read from register 4. Read from a different register first. Read from a different register. So that would be set address 4 cs.low rudba.low print data bus, and that should give us some garbage. I don't care. Rudba high rudba low. Whoa. CS high. Okay. Set address 7 we're looking, that bit should be high. It is currently grounded, so it should be high. And all at once now, cs.high rudba.high. This thing is blazing fast. There should be, it's going to be interpreting, and hopefully it should do this near instantaneously, but anyway, all in one. CS high, rudba high, and print data bus. Well, no, let's not do print data bus right away, because this isn't a fast chip and the bus needs to settle. Print data bus. Yep. So that is definitely a problem then. Let's just be sure by deasserting cs.low rudba.low. Wait. I need to go. cs.low, they were already high. rdb.low, they are active low signals, you psycho. Okay. All right. So these lines didn't change anything. Print data bus. Okay. Now that's not conclusive. I would have to look on the logic analyzer or like keep doing this over and over again and put it on my analog oscilloscope or something to prove that it really doesn't matter that you do those at the same time. But I don't know, man. Okay, here's what we'll do tomorrow. One thing that we can definitely do. Still have to figure out a way to reset this thing. There's apparently no reset pin on the cartridge, which is weird. And I don't really want to like run a wire to the inside of the NES, but but so maybe I'll just like reset it externally for right now. Plug this goddamn thing back into the NES. Try reading that register like we just did. I bet it won't work, but I gotta go. Wareworm says just use the same pin. Which pin? Are you talking about the drive detect pin or the disk detect pin? Because yeah. But the same pin for reset? I'm saying there is no reset pin. Oh, blah, 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 blah. Wareworm says, you mean just connect one Pico pin to both on the controller? Oh, the same Pico pin for read and chip select. Yes, one would think. Oh. God. See, this is why I have to go. Fuck. Giving me a good idea, but also I have to go. Duh. Fucking duh. Yeah, let's do that. That makes sense. Literally on the hardware. Connect them to the same fucking pin. You dingus. Put this over here. This is chip select. Now we need one more wire to connect chip select back up. Only dip thingy doodad. Who am I? Where am I? Hello, I've forgotten my name. Is that you, Aunt M? Is that you, Aunt M? Daisy, Daisy, give me your answer due. Okay. All right. Wareworm says, and solder a manual reset button while you're at it. You know what? that might be fun. That might be just fine. Why the hell not? Okay. Initialize the whole thing, do the stuff. Okay. We do need to write some functions for this so I don't keep messing this up, but let's initialize some things first. Let's make sure CS is high. Let's make sure read B is high. Let's make sure write B is high. Let's make sure, what else do I need to do? We haven't reset it yet, so anything, I mean, I just have the address. Let's set the address. Set address 7. No, not prematurely doing things. Reset. Low. Reset. High. Reset. Low. And I don't want to mess this up. I guess I really didn't need to set readme high, huh? It's not connected. It sure shouldn't be. Let's do a sanity check on that, because this is about proving a thing. So let's actually set readme low and make sure they're both high over on the PCB. Surely there's entertainment value in watching these streams, just watching me spiral. Okay, so chip select should be high, and it is. Write should be low, it should also be high, and readme should also be high, and good. Good, good. Even though I just set readme to low. Good, good. Or rather, the readme that's here in the code. Blah, 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 blah. Chip select high. Write B high. Reset the damn thing. Reset low. Reset high. Reset low. Set address 7. That is still grounded. Should be as easy as setting CS low, huh? Huh? Let's just make sure there's nothing on the data bus. There's nothing on the data bus. CS.low. Print data bus. It doesn't matter. Thank you a ton, Wereworm. Confirmed. Amazing. Okay, I really have to go. I really have to go now. I really have to go. I really have to go now. I really have to go. Okay, bye. No more outro than that. This thing works. These are the things that from all of this we have learned, that we have confirmed. I put enough work into it that let's make sure I say we have confirmed the floppy drive controller works. We have a register that we can read and make sure it's doing the right thing. And it does not matter, at least for this particular chip, if chip select and read or write are asserted at exactly the same time. Even though the data sheet says you need to give it at least 5 nanoseconds. That is either a lie or, you know, this is just out of spec enough to be fine. These things we have confirmed. Okay, peace out. As always, see ya. Love ya. Bye?